Hello everyone, my name is Nakul and I welcome you all to another episode of Tech Treats, the Opcito Podcast. For today's discussion, we have an interesting framework that has facilitated not only learners but also developers across the globe to build cutting-edge applications. As per the 2022 Stack Overflow survey that involved more than 70,000 developers across the globe for web frameworks and technologies such as React, Angular and Vue, a whopping 42.62% respondents said that React is their preferred framework. You can find link to the survey in the description below. Considering that React is one of the most favored framework, our product engineering team decided to come up with some easy peasy optimization strategies that will help you optimize the performance of your React applications. With me today is Kanishk. Kanishk is a senior developer at Opcito Technologies. He's passionate about new trends and technologies and has over 7 years of experience with frameworks such as TypeScript, JavaScript, and tools and technologies such as React, Angular, Vue, Node. Welcome, Kanishk. How are you?
Hey Nakul, I'm doing great, and thank you for the introduction and having me on this podcast today.
Okay, so Kanishk, today's discussion is about React, right? And React has been there for more than a decade now. But the traction it has been receiving is over the last 5 years. So what has changed?
Yeah, I'm also using React since 4-5 years, and basically I have tried my hands on different frameworks and libraries as well. I have been using React and Angular for a few years, and I have also tried my hands on other frameworks like Angular and Vue. The fundamental difference between React and Angular that we all tend to forget sometimes is that React is a JavaScript library, whereas Angular is a framework. So when you build an app with React, you are only using JavaScript with JSX, whereas with Angular, you use JavaScript plus a framework. The component-driven architecture of React allows developers to reuse code components. This helps in saving a lot of time. Also, React has better performance, smaller bundle size, and backward compatibility. And most notably, due to its rendering optimizations and virtual DOM implementation, it outperforms Angular.
So that explains the numbers behind React. Now coming to the central part of this podcast, which is optimization strategies. You just spoke about rendering, and there is a way to render which is using React DOM. Are there any alternative ways to this?
Yes. I prefer methods like create true instead of React DOM render. Here is why. To render components in a new way with better performance and better support for concurrent mode, React 17 introduced in a new method called create root. The fundamental operation for create root is similar to that of React DOM.render, except that it creates a new root container and returns a reference to it rather than rendering to a particular DOM node. Then you can render your components to the root container using the return reference. For instance, instead of the DOM displayed on screen, we can use this. So with create root and the associated root.render function, you can run multiple calls to render using the same container DOM element. Unlike React DOM.render, in which every call to render requires a new call to the document API. You can avoid multiple searches of the DOM by storing the root element in a variable, but the new root API with create root maximizes readability. Long answer short, the primary distinction between create root and React DOM.render is that create root generates a new root container for rendering components, whereas React DOM.render renders component directly to a given DOM element.
Another thing that is discussed these days is React fragments. How does it really help?
With React fragments, we can avoid additional HTML element wrappers. We can render multiple elements of a component without adding extra div tags. Also, we can write cleaner, more readable code with React fragments. It takes up less memory and renders components faster. Each component is rendered as expected. React fragment is a component exposed by React, which serves as a parent component in JSX, but does not add anything to the DOM. On the other hand, the div element is an HTML element with no semantic meaning, but will be added to the DOM as a node when used. React fragment and div can both serve as parents for grouping children components in a valid JSX syntax. However, only a div can appear on the screen. Only the div accept classes that you can use to style the container or the children components. Another important thing that I want to highlight is React fragment only accepts the key attribute which every element including the div accepts. But after compilation, the fragment component does not get to the DOM. Thereby, you cannot use it on the UI. One thing I would recommend here is to use React in strict mode. React strict mode is a developer tool highlighting potential bugs or issues in a React application's codebase. It provides warnings to developers as feedback for errors that occur in an application, with no effect on the result because it does not render any visible UI. React version 18 added new features to the framework and improved some existing features significantly. React strict mode runs some functions in the development environment to ensure that they return values identical to the desired arguments and have no unintended side effects. Now there are three functions: functional component, initializer function, updater function. Strict mode, on the other hand, detect errors in coding patterns and flags previously accepted bad syntax as errors by eliminating silent errors and throwing errors when they occur. React strict mode works similar to JavaScript's use strict expression, ensuring a more strict and type-safe version of JavaScript. Undeclared variables will return an error in React strict mode. It checks for the following. Number 1. Components with unsafe life cycles. Number 2. Usage of legacy or deprecated APIs or methods like the string reference API and context API and find DOM node. Number 3 is unexpected side effects. You can reference the strict mode by using fragments like react.strict mode or by importing the strict mode directly from React in your code. Then the component can be called strict mode. You can see on the screen the code to wrap the suspected code in the strict mode helper component.
So Kanishk, we tend to use lists a lot during our coding, right? So is there any optimized way to use lists in React?
Actually there is. You can use a key prop. A key prop can help you optimize the running of the list in your web application. By providing a unique key for each item in the list, React can efficiently update only the items that have changed, improving the performance of your web application. On the screen is the code snippet that will give you a clear idea.
So lists are an important part of any application, as we spoke, right? So any tips around virtualization of lists?
Yes. So when your application renders long list of data, say hundreds or thousands of rows, so I would recommend you the technique like windowing. This technique only renders a small subset of your rows at any given time and can dramatically reduce the time it takes to render the components and the number of DOM nodes. Already created React Window and React Virtualized are popular windowing libraries. They provide several reusable components for displaying lists, grids, and tabular data. You can also create your windowing component like Twitter did if you want something more tailored to your application's specific use case.
Earlier we spoke about DOMs and we just talked about props. What is the easiest way to spread props over DOM elements?
I think you should avoid spreading properties into DOM as it adds unknown HTML attributes and as shown on the screen, which is unnecessary and bad practice. Instead of spreading props, you can set specific attributes as shown on the screen.
So Kanishk, let's just continue on props. How do you validate props in React?
So when defining a React application, you must structure and define your props in a way that avoids bugs and errors. Just like a function might have mandatory arguments, a React component might require a prop to be defined. Otherwise, it will not render correctly. Forgetting to pass a required prop into a component that needs it could cause your app to behave unexpectedly. This is where React prop types validators come in handy. The prop types utility exports a wide range of validators to configure type definitions. I am displaying a list of available validators which are widely used to validate the prop types.
As you know, images have a significant impact on performance of any application. Large and uncompressed images severely affect the performance. Is there a way to optimize image loading?
You are right, Nakul. Nowadays, the image optimization is not optional anymore. It is mandatory as the application performance is dependent on it up to some extent. So here are some easy tips for optimizing image loading in React. Like compress images. Compressing your images can significantly reduce their file size, making them faster to load. You can use online tools or image optimization libraries like ImageMint to compress your images. Second one, use the appropriate image format. Different image formats have different file sizes and loading times. For example, JPEGs are good for photographs while PNGs are suitable for graphics with transparent backgrounds. Choose the appropriate image format for the type of image you are using. And the third one is use lazy loading. Lazy loading is a technique that allows you to load images only when they are needed. This can significantly reduce the initial load time of your web page. You can use third-party libraries like React Lazy Load to implement lazy loading in your React application. Fourth one is use responsive images. Responsive images can help you load smaller images on smaller devices and large images on larger devices. This can help you improve the loading time of your web page on different devices. And the last one is use a content delivery network, that is CDN. A CDN can help you deliver your images faster by caching them on multiple servers worldwide. This can significantly reduce the loading time of your images.
Rightly said, Kanishk. Images are vital part of aesthetics of any application, and the best practices that you just mentioned for image optimization can help us improve performance of React applications. So another important aspect of any application, especially while designing, is styling. Could you please tell us best practices for styling in React?
Yeah, so the first one is using the external style sheets. External style sheets can help you separate the styling from the markup, making it easier to read and maintain your code. You can create external style sheets with CSS, SAS, or other styling preprocessors. Second is using CSS modules. CSS modules allow you to write modular, reusable styles for your components. This can help you avoid naming conflicts and improve the maintainability of your code. Next in line is using a CSS-in-JS library. CSS-in-JS libraries like style components or emotion allow you to write your styles directly in your React components. This can make your code more readable and maintainable. Also, we should have a design system. A design system can help you maintain a consistent style across your application. By using a design system, you can avoid duplication of styles and improve the maintainability of your code. And the last one is optimizing the CSS. Optimizing your CSS can help you reduce its size and improve the performance of your web page. You can use React developer tools like Purge CSS or Post CSS to optimize your CSS.
So there is one more term that I often hear, that is memoization. Could you please throw some light on memoization?
Yes, memoization is another technique that makes application more faster and efficient. It does this by storing computation results in a cache and retrieving that same information from the cache the next time it's needed instead of computing. It does this by storing computation results in a cache and retrieving that same information from the cache the next time it's needed instead of computing it again. Simply put, it stores a function's output in a cache and asks the function to check if each required computation is in the cache before computing it. React provides pure component and memo to implement memoization. Pure component is used with the class component and the memo is used with the function component. Memoization increases performance by storing results for functions when the same prop is passed, hence reducing the number of re-renderings. However, overuse of memoization in places without performance issues can hamper performance. Memoization is a simple but powerful trick that can help speed up our code, especially when dealing with repetitive and heavy computing functions. You can see an example of memoization on your screen. There is one more thing that I want to add, and that is trimming JavaScript bundles. If you wish to eliminate code redundancy, learn to trim your JavaScript packages. When you cut off duplicates and unnecessary code, the possibility of your React app performance multiplies. you must analyze and determine bundle code.
There is one more aspect that I wanted to know about, that is suspense component. So is there any change made to this suspense component, and how do you use it on the client side?
Yes, so the suspense component was introduced in React 16, I think, and that was work with React Lazy only. Basically, it allows component to be suspended while waiting for the specific bundle to be loaded. However, it could not be used for data fetching initially. This limitation has been addressed in the latest version of React, making it possible to use the suspense component for data fetching. The suspense component simplifies the asynchronous data fetching process and loading display. It can be wrapped around a component that handles the data fetching, enabling developers to display a loader component coded in a declarative way in their layout. You can see on the screen an example of the previous method of incorporating loader logic within a component to display loading code.
So Kanishk, how has rendering changed over the years? I mean, the concurrency in React, is it still the same or has it changed something?
Before React 18, rendering was single, uninterrupted, and synchronous transition basically. Once it started, it can't be interrupted. React 18 introduces the foundation of concurrent rendering and new features such as suspense, streaming, server rendering, and transitions are powered by concurrent renderings. React 18 introduced a new concurrent rendering engine which has been optimized for both front-end and server-side rendering. This shift to concurrency streamlines the process of rendering the UI both on the server and the client side. As a result, user can interact with the page sooner, providing a smoother experience even on heavy data-centric pages. Much of this is implemented as a part of enhanced suspense component. It's important to note that React guarantees a consistent render. In practical terms, if you use React without external stores requiring synchronization, React will handle rendering using its concurrent capabilities and guarantee consistent rendering. If you primarily write pure React using the use state hook, you can expect shorter waiting times with consistent results.
So now there are multiple modules and components in any React code, and we may not need some of them. So what should we do in such a scenario?
There's a solution. We call it code splitting basically. Let me tell you what code splitting does. A typical React application comprises dozens of components and code, but you don't need to load most of these components when you load them for the first time. Code splitting entails splitting out the different parts of your application and only loading them when needed. This is far more efficient than loading the entire application at once. Usually, the browser downloads all the files in your project on the initial page load. This may slow down your website if it contains a lot of files. Now imagine the number of files for a huge project. In such a case, downloading the entire application files simultaneously can take a very long time, so splitting that up is quite beneficial.
This is interesting. So what are the functions and components involved in code splitting?
Maybe I want to talk first about the code splitting functions.
Okay.
The first one is using dynamic import. You can export any method or utility function and import it lazily and dynamically when needed. For example, you want your homepage to have a button. When you click the button, you want to display the sum of 2 and 2, which is 4. So you can create a home.js component and define the view of your homepage. In this case, you have two options. First, you can import the code for adding the numbers at the top of the home.js file. But there's a problem. If you import the function at the top of the file, the code will load even when you have not clicked the button. A better approach will be to load the sum function, which only when you click the button. To achieve this, you will need to perform a dynamic import. This means importing the sum function inline in the button element. This is how the code will look like. Okay, now coming to code splitting components, you can use React Lazy and Suspense. The best place to perform code splitting would be inside your router because this is where you map components to routes in your application. Suppose that your app has a home, about, and products component. There's no point in loading about or product components when you are at the home component. So splitting them away from the home would be best. The code on the screen will help you understand it better. You need to import the required functions and components from the React and React router DOM modules.
Okay, this is definitely helpful. Give us some tips around server-side rendering, how we can optimize that side.
Yes, you can definitely try a few things, and I'm sure that help you a lot. First, user cache. Caching the server-side rendered HTML can help improve the performance of your web application by reducing the time to interactive. By caching the server-side rendered HTML, you can serve the cached element to subsequent requests rather than re-rendering the HTML on the server. Secondly, use a CDN. Using a CDN, that is Content Delivery Network, can help improve the performance of your web application by serving the server-side rendered HTML from a geographically distributed network of servers. This can reduce the latency and improve the time to interactive of your web page. Then you can also optimize your server-side code. Optimizing your server-side code can help improve the performance of your web application by reducing the time it takes to generate the server-side rendered HTML. You can optimize your server-side code using caching, pre-rendering, and other optimization techniques. Another thing you can do is using lazy loading. Lazy loading can help improve the performance of your web application by deferring the loading of non-critical resources, such as images and videos, until they are needed. This can reduce the size of the initial HTML payload and improve your web page time to interact. Lastly, as I have already told you about optimizing your images can help improve the performance of your web application by reducing the size of the initial HTML payload. You can optimize your images by compressing them, resizing them, and using modern image formats like WebP.
And what about dependency optimization?
Okay, so when you are using some development dependencies in your application, it becomes crucial to check how much functionality you are using out of large amount of functionalities that is included by default. Okay. This is where we can use tools like the Webpack Bundle Analyzer plugin that displays an interactive graph with the result of our bundle, what dependencies it contains, and how much they weigh. If after the analysis, you find that you only use a small amount of CSS styles from the Tailwind CSS framework, use tools like Purge CSS to help minimize the amount of CSS files in your final bundle. Vite is a build tool that is designed to be fast, lightweight, and easy to use. Vite uses a modern, modular approach to building web applications, and it's designed to take advantage of modern browser features like ES modules and dynamic imports.
Okay, but why Vite?
Firstly, it provides faster build times. The most important feature is it provides significantly faster speed. Vite was designed to be fast and efficient from the ground up, making it an excellent choice for modern web development. Unlike other build tools, Vite uses a module-based approach that only compiles and reloads the change code. This means that you don't have to wait for an entire build process to see your changes in the browser, which can save you a lot of time during development. Another advantage of using Vite is its seamless integration with other tools in the web development ecosystem. Vite supports many popular front-end frameworks such as React, Vue, and Angular, and it's easy to integrate with other tools like ESLint and Prettier. Additionally, Vite has a built-in development server that provides hot module replacement and fast refresh, which makes it easy to iterate on your code. Vite was designed with speed in mind. It takes advantage of modern browser features like ES modules to provide near instantaneous page reloads during development. This means developers can change their code and see the results in the browser without waiting for a complete build process. Vite accomplishes this by bundling and serving the code on the fly rather than creating a pre-built bundle. Vite also supports asynchronous loading of modules, which allows it to load only the necessary parts of the code that are needed at the time. This approach significantly reduces the amount of time required to build and serve a web application. In Vite, HMR means hot module replacement is performed over native ESM. Vite invalidates the chain between the edited module and its closest HMR boundary when a file is edited. This makes HMR updates simple and fast regardless of the size of your application. Modules are fetched over HTTP requests. Vite leverages HTTP headers for caching to speed up full page reloads. Source code module requests are more conditional via 304 not modified, and dependency module requests are cached via cache control maxage, that is something 315.36.000 immutable. Vite automatically extracts the CSS used by modules in an async chunk and generates a separate file for it. The CSS file is automatically loaded via link tag when the associated async chunk is loaded.
So that means Vite is all about speed and optimization, right?
Yes.
So coming to the latest release of React, I think React 19 is here, right?
Yes.
So what has changed? What is new in React 19?
See Nakul, the React 19 is introduced to provide better performance and developer experience. So I'm hoping this was kept in mind when they are releasing this version. For example, concurrent rendering. Concurrent rendering allows React to prepare multiple versions of the UI at the same time. This improves the responsiveness of the applications by ensuring that high priority updates are handled first without blocking lower priority updates. Now the benefit it brings to the table include improved responsiveness. React can prioritize urgent updates such as user input over less critical updates. And the second one is better resource utilization. By managing updates concurrently, React can make better use of available computing resources. Another feature is about data fetching suspense. It lets components wait for some time before rendering. In React 19, suspense now supports asynchronous data fetching, making it easier to handle loading states in UI applications. Now this helps us in two ways. First is simplified code. We can directly handle asynchronous operations in component tree. And secondly, consistent UI which automatically manages loading states and prevents flickering. Another interesting feature that grabbed my attention is the new JSX transform. The new JSX transform simplifies the compilation process and reduces the size of the React library that needs to be included in your project. This helps in reduce bundle size, and smaller bundle sizes can lead to faster load times. Second benefit is simplified setup. Now you do not have to import React to use JSX. Next on my list is improved server-side rendering, which is called SSR. React 19 has made SSR more efficient and faster, and this means faster rendering with improved algorithms to reduce the time it takes to render components on the server. And better SEO with improved search engine indexing. And lastly, automatic batching of updates. To be honest, it is my favorite feature because it allows multiple state updates to be grouped together, improving performance by reducing the number of re-renders, which is quite frankly frustrating sometimes.
You're right.
Yeah. And fewer re-renders and automatic batch updates means saving a lot of time. Now, in addition to these 5 features, there are some performance improvements too. These improvements are designed to optimize rendering processes and reduce the load of the main thread. The primary performance improvements in React 19 includes optimized concurrent rendering with improved algorithms for managing multiple rendering processes simultaneously. Better memory management with enhanced memory usage, reducing the likelihood of the memory leaks and improving overall application stability. Now, if you compare these updates in React 19 with React 18, which is exactly what has been done already with respect to performance gains and several benchmarks, the key results show 20% improvement in rendering speed for complex UI components, 15% reduced memory consumption approximately, and 10% faster load time on average, thanks to optimization in the initial rendering process.
Wow, Kanish, these are really interesting numbers. And the information that you provided today on the React optimization strategies will definitely help people who are working on React to improve performance of their React applications. Thanks to you.
Yeah, I'm also hoping that everyone will try these techniques.
Yeah. Thank you everyone who joined us today.
Yeah.
We'll meet in next episode with another interesting topic. Till then, take care. Bye-bye.